This episode of the Pumps and Systems podcast is brought to you by Industrial Flow Solutions, intelligent pumping solutions.
So when you look at the more cloud-based monitoring systems, you can get access to not only the raw data that you would from a traditional system, but these systems will also do analytics on top of that. By taking the raw data and the process data and doing the analytics either at site or on the cloud-based system, that's what brings you this more actionable insight.
Hello and welcome to the Pumps and Systems podcast. I am your host, Tom Baer, a managing editor at Pumps and Systems magazine. Today we're speaking with Graham McIver and Jordan Boone from Industrial Flow Solutions, and they're going to be telling us all about connected technology and its role in the pumps industry. So without any further ado, let's get into the episode. All right, so welcome to the Pumps and Systems podcast. We're very happy that you're here. So how are you two doing today?
Good.
Great.
Good and great. Glad to hear it. Okay. So before we get into our main topic, would you mind introducing yourself? So tell us a little about who you are, what you do, anything that you think our listeners and viewers might want to know.
I'll go first if you want, Jordan. So I'm Graham McIver. I'm the VP of Global Engineering at Industrial Flow Solutions. So I started out my career just about 20 years ago after university in electrical engineering. Started off doing control system design and power systems, and then moved into the water industry about 15 years ago, predominantly doing control systems for pumping systems, and then went through and developed a product for solving a problem with pump blockages, and had the joy of partnering up with IFS back in 2021, where I joined IFS and currently work there.
I'm Jordan Boone. I'm the technical support manager for Industrial Flow Solutions. I started my wastewater career in 2005. I started for working with CH2M Hill in the Villages in Florida, and did that for a few years. And then I moved out west to Utah, worked for Provo City, South Valley Sewer District, and then that's how I came to work with DRAGger and Industrial Flow Solutions. So that's kind of my background, and I've got all my wastewater operator certifications, so operators certification, collection system certification, and maintenance certification. So I've been kind of hands-on, and then moved later on in my career. I moved more into controls, SCADA programming, and then that's how I came to know Graham, was through moving into that side of things.
Great. All right. Very good introductions. Thank you. So then today we're going to be talking about connected technology and things like that. So why don't we start with the basics? So can you tell us what exactly is connected technology and why do we need it?
You know, more and more customers are looking for real actionable data from their assets. Connected technology is where sensors and assets are connected to the cloud or to each other to build a better picture of what is happening on site. Historically, we needed this because, for example, you get an alarm and it just tells you that there's a problem. It doesn't really go into much information other than maybe the pump is tripped. So this means someone ultimately has to go out to the on-site, to the pump station, and see what really is going on. So that first responder shows up. He may or may not have the right tools to fix it. He may or may not be the right guy to fix it. So, for example, the on-call operator, receives a call from that pump number 1 is tripped. So he shows up after having really no information other than that. He goes out there to the panel and sees that the pump is tripped. He resets the pump, and as soon as he puts it back in the hand or auto, trips right away. So he's not the electrician. So he's going to dig into the pump side of things to see kind of what's going on. So, his first action would probably be to pull the pump, see if there's anything stuck in the impeller. And if you pull the pump and you see nothing's there, then next thing he's got to do is call the electrician to come out and do his thing and look into the control side. Imagine you have a smart device connected to your pump, and it tells you in real time what the voltage and amperage look like. And then you can take that information and see that maybe phase C that has no readings. So right off the bat, as soon as the on-call operator gets the call and looks at that information, he can see that, there's no reading on phase C. I need to call the electrician right off the bat to go out there and check things out. So that right there fixed all of his wasted time that he would have spent driving out there, pulling the pump, seeing what's going on, just to see that he didn't need to go out because it's not his expertise. So if you have a connected device that can give you that information in real time, it saves a lot of hassle, saves man hours, saves stress on vehicles. And then for another example, say another common problem is that you go out, you get a call, the on-call guy does, and the pump's been running constantly for hours, and now it's tripped out. So this whole time it was running, it was sucking air. So with it being a submersible pump, there's no cooling on the motor. So after it's been doing that, could be possibly all night with the floats being tangled up. Next thing you know, your windings have pretty much melted, and you have to replace the pump now. Where if you had a connected device that was smart enough to tell you, hey, we've been running for 60 seconds with barely any amperage, something's wrong. I'm going to trip this pump. So if you have that kind of technology, one, you save the pump, and because the whole time it's sitting there running, it's just wearing itself out and ruining the pump. Where if it trips after 20, 30, 60 seconds, it'll save the pump, save all kinds of hassles from having to then occur. That's why it's important.
So if someone wanted to implement this type of technology, what would their options be?
There's a few different types of options you could do for this. So, for example, you could install maybe a complex custom PLC system, or you could go down the route of installing remote telemetry units, RTUs, at your station. This might be a basic PLC, or it could be a specific RTU systems. And this would tie back into a totally integrated SCADA solution. Or you can get a lot of smaller cloud-based smart sensors are available in the market now. These are actually quite low cost as well, quite easy to install. And they tends to send data back to their own cloud platform. So, you'll pull out a smartphone and have a look and see what the current of a motor is, for example. Or you can get more sophisticated cloud-based monitoring devices.
So could you run us through these technologies? Tell us a little more about them.
So a complex PLC system, that would be where a user would install a PLC system. They might already have a PLC system at their station. Around maybe 50% of lift stations in the US might have a PLC there that does the control. So you would have your control system, you would take all your signals back to that, your runs, your trip signals, your alarms. You might even bring some sensors back to that, such as levels and flows, to do the control. And then you would then have software on there that could be custom made to then give you more analytical data. But, PLCs are not tended to be designed for doing the analytics and the kind of data side. They're more for doing logic control. So this is where the RTUs are more in this space, where they're taking signals into their system and then sending them to a SCADA system or a platform. SCADA systems, and they charge per tag. So you've got to be very conscious of what tags you're bringing back. So that's why traditionally you've tended to just bring things back like trips or high-level alarms. You're minimizing your monthly costs by reducing that. But these systems, again, they bring back limited data, but you could have different systems on each site. So you might have one manufacturer's SCADA system on one plant coming back to your SCADA, and another piece of equipment that's coming back from a different site. So the uptake and the maintenance just to maintain your SCADA system is quite a lot as well. And then moving on to the smart sensors, as I said, the smaller kind of clip-on modules that have their own cloud-based platform. A lot of these sensors, they have their own platform. It might just tell you the running current of your pump, but it doesn't tie in or integrate with the level, or it doesn't tie in with the kind of health of your pump per se. So again, you might have to load up one application on your phone for your level sensor. You might have to open up another application for the power monitor on your site, and it's not really tied together. And it also tends to be on the manufacturer's cloud platform. You can't really get access to that data other than downloading it from their website. Then when we move on to kind of more cloud-based monitoring systems, these are more of the true IoT devices. So these are systems that plug in, might be smart sensors as well, but they tie back into third-party cloud systems and tend to be open platforms. Things like Microsoft Azure or MQTT type data connectivity. And when you have devices like this that can talk to those platforms, this can tie into your much more enterprise-wide system. So you can actually then have communications from site to site. If you tie into your Microsoft Azure environment, if you're on the Microsoft environment, you can tie into Power BI, so your C-suite execs at the municipalities can start getting reporting. You can tie into MS Dynamics, where you can get work orders being raised, and you can really make the system a lot more connected and integrated and smart. So not only are you tying into the operations and maintenance level, where they're getting actionable insight to this is what's happening with my station, this is the person I need to send, you're actually tying into the higher level where you can actually raise the work orders to say, okay, go straight to the electrician to send the electrician to site. And that's the kind of key differences between these technologies.
So where would you install this type of technology?
There is a place to install it everywhere, but most of this time the remote stations are the key place, because you don't have operation staff there. And as Jordan alluded to earlier, if you're sending an operator 50 miles in his truck to a remote station, that's more wear and tear on his vehicle. It's also more chance of wasting time while he's driving there and driving back. So these are the stations where you really want to get as much information as possible, so you're minimizing the wasted trips to that site. So instead of having 3 or 4 sites to determine what's wrong, you would just send the correct person in the first place to go and fix the job at hand.
So then can you expand on the role that cloud connectivity plays with this kind of technology?
With this technology, you usually have multiple connectivity options like Modbus TCP or Modbus RTU that would allow you to connect your data to the cloud. And we have clients that have built platforms that are in the process of building platforms that take the data that they collect from their smart devices and send that information to the cloud, and then they add some analytics to it, so they can build their own predictive maintenance kind of platform. That way, when there's a problem, it helps them predict the problem more than being reactive. So, for example, our technology utilizes dynamic torque monitoring to monitor pumps and cloud connectivity, and that plays a significant role in enhancing the effectiveness of dynamic torque monitoring. And with that dynamic torque monitoring, we can use real-time pump protection to look at the health and well-being of the pump by looking at the 3-phase power signature to determine if the pump's clogging, and also while it's looking to see if it's clogging, it's also looking to protect the motor from any damaging conditions that could be occurring. So by connecting your system to the cloud, you can access this real-time data from anywhere, which would allow more flexible and immediate responses with any issue that could possibly arise. It also allows for easier data analysis and sharing among team members, which can also improve decision-making and the overall system efficiency.
This episode of the Pumps and Systems podcast is brought to you by Industrial Flow Solutions. Headquartered in New Haven, Connecticut, USA, Industrial Flow Solutions specializes in the design, manufacturing, sales, and service of wastewater pumps and controls, including Overwatch direct inline pump systems, BJM pumps, Drano pump, Stancor, Oilminder, and D-Ragger products, ideal for municipal, industrial, commercial, and residential applications. For more information, visit www.flowsolutions.com. What type of data comes out of this technology, and what can you do with that data?
So when you look at the more cloud-based monitoring systems, you can get access to not only the raw data that you would from a traditional system, but these systems will also do analytics on top of that. So they'll take that raw data, they'll put some analysis on it. As Jordan was saying earlier, you monitor your pump. You're not just giving, say, for example, your amps. If your amps drops down, your pump's running in a particular way, you could say, well, actually, my pump's running dry. And then you could then alarm to say, my pump's running dry, you could tie that back with your level signal. Actually, my level signal is still saying I'm high, so maybe the level instrument's at fault here because it's getting a false reading. By taking the raw data and the process data and doing the analytics either at site or on the cloud-based system, that's what brings you this more actionable insight. When you put the cloud monitoring system separate from a PLC system, the data sets are all the same. So, if you take, say, for example, a power monitor product and stuck that in a panel, your data sets are a cookie cutter. So everything is arranged in the same order. So your run signal is always on the same variable. Your trip signal is always in the same variable. So when you do the programming on the top end, it's a lot simpler. You're not having to map everything through from the source. All the source signals are all in the same place for each station. So you just copy and paste it. One of the other things as well is when Jordan was talking around with the dynamic torque monitoring, if you utilize that data to control the pump and do, say, for example, a reversal to clean the pump, this allows you to get clean data. And when we talk about clean data on our company, we're not just talking about the pump being clean. What we're talking about is that if you have a PLC system or an RTU, and say, for example, one of the relays in the panel goes bad, or an electrician accidentally disconnects one of the signal wires, like a high-level float switch or a trip signal. Now, that trip signal can happen at your station, but might not get reported through due to a fault in the panel. With the smart sensors, when you're adding these to the panels, they're generating the signals themselves as well as transmitting the data. So if you were, we're generating, for example, we're monitoring the current ourselves, and we're determining that the pump is running dry ourselves. So we're not relying on third-party sensors or wiring to come back to our system to get that. So the data integrity is a very key piece to using smart sensors. And also when it comes to clean data from a pump being actually physically clean perspective, one of the drawbacks to this technology historically has been, this is great, we have all this data coming into us, but the problem is it sends me an alarm every 2 seconds. So my phone won't shut up because it's ringing off, pump trip, pump alarm is going to fail, etc. We send people to site and it turns out that the pump is racked, or it's something that's more of a regular maintenance occurrence rather than a critical failure. With our technology that we use anti-ragging in our system, and that actually keeps the pump from being ragged up, and it keeps it clean. So this means that we can determine when a pump is ragged or when it's actually motor failure, because these are very different signatures for us. So when your pump is running, we'll detect there's a blockage, we'll do a reversal, and we'll carry on and keep the pump clean. However, if the bearing is starting to fail, that has a different signature. So we know the difference between the two. So we're not giving you the false positives you might have been getting from traditional systems. And that's one of the key challenges you have to overcome when it comes to data connectivity, having reliable data that you can send to the cloud.
That makes a lot of sense. Okay. So you mentioned clean data. So can you tell us a little more about that? Like, what exactly is clean data?
So clean data is where you're creating reliable data. It's all about how much confidence do you have that signal and that data that's coming in is accurate? It goes down to this false flag is this really a trip pump, or is this really a ragged pump, or is this really a pump that's running dry, or is this a sensor that's not picking up a signal correctly? And clean data is a key part. And just looking at one signal, say a high amps or a trip signal, or even a high level, that still might not give you the full picture of the station. The key is tying the signals together, and that's what wastewater operators on site are very good at doing. They can look, they can smell, they can listen to what's going on, and it gives them that feel for how the station's operating. When you're just sending, raw signals back to a SCADA system, you're not getting that same connecting the dots of the different data points, and that's one of the key parts of that.
Do you have any real life examples or real stories that you can share with us about anything that we've been talking about today? Because people always enjoy hearing the real stories.
Do you want to go first, Jordan?
Sure. So, there's, in the beginning, I was talking about being the on-call guy. I mean, that was me. I was the on-call guy. Many times getting woken up at 2 or 3 o'clock in the morning. And early in my career, I didn't have a whole lot of electrical experience. That came later. So, I'm not an electrician, but I got a pretty good handle on it. So in the beginning, when I was on call and got called out to a pump station, I had to go and and pull the pump. I had to go do my side of figuring out, is it just the clogged pump and that caused it to trip? Happens all the time. Normally it's the motor overload that's tripping and not the breaker, but once in a while it was the breaker too. So I'd have to go figure that out first. And then after I spent all this time trying to figure that out, turns out it was an electrical problem. So then I'd have to call out our electrician. And so that happened half a dozen times over my career, where if we had some type of smart system installed at the time, it would have alleviated all that pain. And with on-call guys, you usually have a minimum of 2 hours of getting called. If you get called out, they got to pay you 2 hours of overtime. If you're there 10 minutes, or if you're there 2 hours, you're getting paid for 2 hours. So that amount of money makes a big deal in the end. So if you can install one of these devices that takes a simple system and turn it into a smart system, it can save you a lot of time, a lot of headaches, and a lot of money. It is going to cost some money up front, but then it pays for itself pretty quick, especially if you have stations that you have to spend a lot of time at because of whether it's ragging problems or lift station maintenance in general. It definitely helps. So, that's happened many, many times.
Jordan said a very good point there that, by adding some of this technology to your station, you can take those 50% of those lift stations in the US that are just float switch stations with maybe a beacon on top or very rudimentary dialer system. You can install the smart sensor, and then you can tie that back to a cloud-based platform that then gives you that full network connectivity. You're moving your control panel from something in the past that really logic into something of the future that's a full cloud-based connected solution. Over here in the UK, we get a lot of rain, a lot of I&I, particularly because it's all combined sewers. But we did a project where we took our cloud-based system, installed that at lift stations, and they installed smart sensors in the sewers as well. So we could actually fully model the entire network. And by using intelligent pumping, we could schedule the lift stations from pumping from one station to another, so we can maximize the storage within the network. So instead of an event where you had, say, traditionally with your traditional SCADA system, you might have a rainstorm coming in, and you look at your SCADA system and you see the red flashing lights. These are the lift stations that are tripped. And that's where you would traditionally send the crews to go and fix. But if you actually look at those stations might have had 2 or 3 other pumps that were perfectly healthy and able to manage the flow that was coming in. However, you might have had another smaller station that had 2 pumps that weren't tripped but were partially ragged. And those stations might not be able to keep up with the flow. So by taking the data from the intelligent pumping system back to a cloud-based platform, you can actually monitor the performance of each station and say, well, actually, this station can cope quite well with 3 pumps that it has left over running, even though it's tripped. But these stations over here that are not tripped, that are actually partially ragged or not running as efficiently, that's the one that's going to actually spill. So by using the data, you can start to model and put the predictive as to how your station is going to perform in the future, rather than how it has performed and how it has tripped. And you can only do that by doing the full cloud connectivity and bringing all the data back to a centralized place.
So before we wrap up, do you have any final thoughts or words of wisdom or summarizing statements you want to share with us?
I was just thinking with the condition monitoring, if you got a pump that's supposed to be running at 10 amps and you see it starting to degrade over time, with a smart system, it'll tell you that it's degrading over time, where just a regular SCADA system, it's just going to keep sending you data, and it's just going to be raw data. I know Graham already touched on this quite a bit, but it's your traditional SCADA system that almost every treatment plant has. You're getting raw data. You've got to have someone, you got to have an operator there smart enough to look at it and then distinguish what's going on. And a lot of the knowledge, operator knowledge specifically, is starting to retire, and that knowledge is going with them. So that's one thing that, with a cloud-based system like this, a lot of that knowledge can be integrated kind of into the background of this to where it's more or less just spitting out the information that you really need to know. So kind of like Graham was saying, I mean, that's really what we're shooting for is that network that's connected as a whole, so that you can get this type of knowledge right off the bat, and you don't have to have an operator sitting there trying to distinguish what's really going on. You got the system telling you based on this percentage of change over this time frame that something's going on. You better go check out this station versus another station. So just kind of wanted to add that to it.
Yeah, I mean, historically, people never look back more than a week. No one looks back a date over a year. So, your pump could have started off at 9.5 amps, and now it's running at 10 amps. But, the last 3 weeks, it's still been running at 10 amps. And we've not seen that gradual decay. So, yeah, that's a good point, Jordan.
Okay, well, thank you so much for your time. It's been really great having you on the podcast.
Yeah, thanks, Tom.
Thank you.
Huge thanks to Graham and Jordan for taking the time to speak with us today about connected technology and its benefits in the pumping industry. Also, thank you to Industrial Flow Solutions for sponsoring this episode. If you're listening to the podcast and would like to watch it, head over to our YouTube channel to see the full video version. That's going to do it for today. Thank you so much for watching or listening, and we will see you next time.